Alright guys, like I was talking about, here is the Celwave DL-200, and this is a dummy load with an RF tap. So the antenna goes in this connector. This is an N connector, so if you use this, you know, with HF stuff, you'll most likely have to have an adapter. Typically on UHF and VHF is where you see N adapters in use, N connectors. So you'll have to have an N to PL259 to hook up. This is a BNC connector, obvi, and this is what is called an RF tap. So this connector taps off of the input. The N connector is the input. This is a minus 30 dB RF tap on the actual dummy load itself. This is a 200 watt dummy load. I'll put a link for this down in the description. It is, like I said, a Celwave DL-200. So this is a nice dummy load. It was about $30. It was not expensive. As you can see, it has a pretty stout heatsink here. And for doing anything with a tiny SA or with a regular signal analyzer, a full spectrum analyzer, this is what you want. This lets you not have to fool with a separate attenuator, because this is the attenuator connection right here. So we can hook this up to whatever radio or signal we're looking at and transmit on it with A, the signal goes into the dummy load and not out, and then B, we can hook up our tiny SA or our spectrum analyzer right here and take a look at our signal 30 dB down from the input signal, which is important because a tiny SA is minus 10 dBm, I believe, maximum input level. So you will smoke a tiny SA if you hook it up to a radio and key up on it. So this lets us do that. Now, of course, you know, for added safety, and depending on exactly what you're trying to measure, you could also stick an attenuator on here. So, for example, I have a 30 dB attenuator. I could put it on here, which would mean my test signal is 60 dB down from my input signal if for some reason I had to test something at higher power. I don't know a reason why you would need to test spectrum stuff at a higher power. Generally, I'm sure there's some cases where that would be a thing. In anything I've done so far, there's no need to key up at a higher power level. I'm looking at the signal, not necessarily the strength. Now, if you're trying to see the output power of a signal, then there's a thing. But, you know, other than that. So I'm going to pop this open real quick and let's take a look at it on the inside. Okay, so there's the inside of it. I could take this apart a little farther, I suppose, but I'm not going to. This is our dummy load here. The tap, and this is interesting, the tap here is an inductive tap off of the signal. It is not directly connected. I would assume they share the same common ground, but the center tap is inductive. So that's how this thing is set up. Pretty straightforward, it looks like. Alright, so I'm going to pause the camera and we'll hook this up to probably a Baofeng and the spectrum analyzer and take a look at the RF output and see what it looks like. Okay, I've got the SA set up here and hooked up to our dummy load, and I am the spectrum analyzer, the Regal DSA 815, is hooked up to the input of the signal analyzer, spectrum analyzer, and that's coming off of the tap. So that is set up off of the BNC tap connector. I have a Baofeng going into the dummy load, and the SA is currently set for wattage reading on output. So you can see our reference level is set at 1 milliwatt and we are measuring in watts at the moment. So when I key the radio, you can see that we're going slightly over 10 microwatts, about 14.8 microwatts on transmit. And we have our resolution bandwidth set to 100 kilohertz, excuse me. Alright, and our center frequency is 146.52, which is exactly what I have the radio set on. So as you can see, that works perfectly for testing any kind of signal output off of a radio. And again, you can use this with a signal analyzer, a spectrum analyzer similar to this one, whether it's a Regal or a Siglent or Agilent or whoever's. Or you can use this with the Tiny SA, because the exact same function would work. You hook the Tiny SA's input into the RF tap port on the dummy load, and then that goes into your Tiny SA. And that minus 30 dB keeps the electronics in the spectrum analyzer safe, whether it's the tiny or a regular size one. In any case, that's all I wanted to really show you today. Guys, appreciate you stopping by. Make sure you hit like and subscribe. Make sure you ring the bell so you'll be notified whenever I put out a new video. And as always, 73.